Hey everybody, this is Mr. Mazzoro, and today what I want to talk to you about is salt. Marine science is the study of salt water and the life that lives in salt water. And if we're going to spend so much time talking about salt water, I eventually have to talk to you guys about what do I mean when I say salt water? What is salt in water? And how salty that water is. Are the oceans uniformly salty, or are some areas of the oceans more salty than others? And last, why are the oceans salty? Lakes aren't salty and rivers aren't salty, so why are the oceans filled with salt water and not other bodies of water? And among all these inconsistencies, what is salt, and if the oceans aren't salty, and why are the oceans more salty than other areas on Earth? And what about that salt remains consistent? What about salt in the oceans is consistent? So that's what I really want to talk to you about today. And we're going to start by talking about what salt is. What do we mean when we say salt water? Can you go out and buy a container of Morton salt and pour it in water and make ocean water? The answer is no. The answer is that when we say salt in terms of salt water, marine scientists mean a lot of different particles that all have positively and negatively charged, that are all positively and negatively charged. This means table salt, NaCl. Yes, there's sodium ions and there are chloride ions, positively charged sodium particles and negatively charged chloride particles in salt water. But there's also a lot more than that. There's magnesium ions and calcium ions. There's bromine ions and iodine ions. There's metals like aluminum and copper, and all of these things together contribute to the salt that makes up salt water. It is sodium and chloride, but it's also a lot more than just sodium and chloride. So, how do we measure how much salt is in water? Well, the answer is salinity. Salinity is the term marine scientists use for how much salt is dissolved in water, how many of those positively and negatively charged particles there are in water. And if you take the oceans as a whole and you measure how much salt, how many positively and negatively charged particles are floating around in there, what you'll find is that there's about 35 positively and negatively charged particles floating around in water for every 1,000 parts of water. In other words, if you take 1,000 pounds of water and boil off all the water, what you'd be left with, if that's ocean water, is 35 pounds of salt. In 1,000 pounds of ocean water, there's 35 pounds of salt on average. And I really have to emphasize this. This is average. Obviously, where the Amazon flows into the Atlantic Ocean, there's going to be a lot less salt in that area of the ocean. Some areas of the ocean are saltier than 35 parts per thousand. But again, on average, most of the ocean water is around 35 parts per thousand. This means if you were made out of ocean water and you weigh about 100 pounds, that would mean that if we boiled you off, there'd be 3.5 pounds of salt in you. If you 200 pounds, that would mean there'd be about 7 pounds in you, 7 pounds of salt in you. So where does all this salt come from? Where do all these positively and negatively charged particles come from? The answer is they come from water, sort of. When water falls on Earth, it starts to run downhill. And as it runs downhill, it starts picking up positively and negatively charged particles from the rock and land that it's running over. Sodium ions and potassium ions and magnesium ions. And also, it falls through the air. And as it falls through the air, it also picks up things like chlorides and sulfates and other negatively charged particles. So the more air water falls through and the more land water runs over, the more salt or positively and negatively charged particles water picks up. That means that water in the ocean, since that's going to be that last pooling place of water, is going to have picked up the most ions from land or the most ions from gas. And that's the reason why water in the oceans is salty. It's this last pooling place of water. It collects the water that's run over the most land and fallen through the most air and therefore picked up the most salt. Since water flows into the ocean and only fresh water evaporates, that means that water in the oceans is salty. Water in streams and lakes isn't as salty because it's newer. It hasn't fallen through enough air or ran over as much land. So I already talked to you about salinity, and I talked about where that salt comes from, but what I haven't talked to you about is what is consistent about that salt in the ocean. It wouldn't be true to tell you that the oceans are uniformly salty. They're just simply not. Like I said, there are saltier areas of the ocean and there are fresher areas of the ocean. So what about salt in the oceans is consistent? The answer is it's the salt itself. If you sample any salt from anywhere in the ocean, what you'll find is that the ions and the amount of those ions always remain the same. The proportions of the ions to each other in salt water are always the same. They'll always be, if you sample water from the Indian Ocean and compare it to water from the Atlantic Ocean, about 50% chloride and about 31% sodium and about 8% sulfate and about 4% magnesium. Yeah, the water from the Atlantic Ocean might be a little bit fresher or more salty than the water in the Indian Ocean, but this amount of chloride will make up that salt, and this amount of sodium will make up that salt, and this amount of sulfate will make up that salt in both cases. The recipe for salt in salt water always remains the same. If you boil off any water from any ocean on Earth and you collect that salt and test it, that salt is identical to all the salt in the rest of the ocean. And this is sort of boring on its face, like it's not a very exciting idea just learning that the recipe, the ion proportions remain consistent throughout the oceans, but it's actually a really powerful concept because it means that all fish swim through the same recipe for salt water. It means that when we have an aquarium and we have thousands and thousands of fish, we don't have to mix up a special recipe of salt water for tuna and then mix up a completely different recipe of salt water for clownfish. We can just rely on the fact that the composition of ions in water remain the same and just dump the same recipe of salt water in for tuna and clownfish in any organism in the ocean and know that that's the salt water that they swim through. Even though the salinity of the oceans change, the composition of the salt that makes up that salt water always remains the same. The ions and their proportions to each other always remain the same. So that's it. We learned about what salt is. We learned that it's more than just sodium and chloride. It's a lot of positively and negatively charged particles. And we learned that the measure of the amount of positively and negatively charged particles in the oceans is called salinity, and that the average salinity of the oceans is 35 parts per thousand. That means, on average, if you boil off 1,000 pounds of water, you'd be left with about 35 pounds of salt. In every 100 pounds of water, there's about 3.5 pounds of salt, positively and negatively charged particles that are dissolved in there. And we learned that that positively and negatively charged particles comes from weathering rock as water runs over land and also as water collects them from when it falls through the air. And that means that since the oceans are the last place that water is going to flow into, that it's going to collect that salty water, the water that's weathered the most rock, fallen through the most air, collected the most salt. And that's why the oceans tend to be saltier than streams and lakes that are higher up. Last, we learned that the oceans aren't uniformly salty, but the salt in the oceans is uniform. The salt that makes up salt water always has the same ions in relatively the same proportions to each other. That recipe doesn't change, no matter if you're in the Arctic Ocean, the Indian Ocean, the Atlantic Ocean, or the Pacific Ocean. So that's it. That's basically all I wanted to talk about with salt. I hope I didn't bore you too much with it. I really kind of skipped over a lot, but I gave you the cliffs of what's really, really important to get a good understanding of how the oceans work and what about what is meant when we talk about salt in salt water.